Special segments of similar triangles. So when two triangles are similar, corresponding altitudes, angle bisectors, medians are all proportional to the corresponding sides. So it's not just sides that are in proportion, it's everything in terms of measurement, linear measurement. So altitudes, if we were working with medians or mid-segments, they would be in proportion to each other as well, and to the sides. So in any also in any triangle, any bisector separates the opposite side into segments that have the same ratio as the other two sides of the triangle. So we're not going to be dealing with angle bisectors in this lesson, but that happens to be true. So there are more than just sides that are in proportion. As a matter of fact, in a future lesson, we'll be working with some things that are in proportion. But right now we're going to be working with special segments that are in proportion and to solve a problem. So here we're given that triangle XYZ and triangle PQR are similar triangles. What's the value of x? How can we find this value? So let's write our proportion in words first. Right? So if you notice that the red line's there, and so we're looking to, we've got some measurements there for the two red lines. Those two red lines, those are altitudes. Right? So I put another point in there so I could label it as something. So YA and QB are altitudes to the triangle of the different triangles. Right? And so those altitudes are in proportion to the sides as well. All right, so now let's set up our proportion in words first. All right, so we're going to use the altitude, and we already labeled what that altitude was called, right? So YA. And I'm going to deal with, I'm just going to go from top to bottom. And so in the numerator is going to be triangle XYZ. We always want one triangle in the numerator and the other triangle in the denominator. And so triangle PQR is going to be in the denominator. All right, so YA, boy, I just love those lines. So nice and straight. All right, so segment YA is to, what does it correspond with in the other triangle? It corresponds with the other altitude. So YA and QB correspond because those two are altitudes. And now we just need a side in the triangle. The side we better use better be XZ because we're solving for x, and that's where x is located. We've got all the sides for triangle PQR, but we don't have all the sides for triangle XYZ. So XZ, what side does that correspond with? If you're not sure, it tells you XYZ and PQR are similar triangles. So XZ has got to correspond with PR. Use those triangle similarity statements to help you match corresponding parts. I'm actually going to, let's write that in there. So use the triangle proportionality statement, or excuse me, triangle similarity statement. To match corresponding sides. All right, so let's finish our proportion there. So QZ corresponds with PR. Always a good idea to write your proportion in words first. All right, then we can substitute. And, you know, I'm going to leave off the segments because we're really kind of talking about measurements anyhow, and those lines are just so crooked, they're like drive me crazy. So YA and QB, that looks a little bit nicer, and that corresponds with XZ. So YA and XZ are in the same triangle, and QB and PR are in the other triangle. All right, and we've matched. All right, we've matched corresponding parts. right? YA goes to QB, those correspond. XZ corresponds with PR. So now we'll substitute our values. All right, so YA is 18, and QB is 8, XZ is X minus 1, and PR is 9. All right, so just as a reminder, no cross-reducing. In a proportion, reduce within a fraction or numerators or denominators. Otherwise, you're impacting one product and not the other. We have only one reduction we can make. Right? And by the way, reducing is optional, but it does give you smaller numbers. Both 18 and 8 are divisible by 2. So I could reduce that to 9 and 4. That's the only reducing I can do. All right, so now let's cross multiply. So we have 9 times 9 equals 4 times x minus 1. And I'm going to put a little reminder here to not forget parentheses. All right, so don't forget parentheses. You have to distribute. To a sum or difference. All right, because we're multiplying 4 by all of x minus 1, right? The x and the 1. So this is 81 equals 4x minus 4. All right, so let's add 4 to both sides. So we have 85 over here equals 4x. And then we can divide both sides by 4. Right? And that doesn't simplify at all. So not necessarily pretty, but we have solved it out. And I'm just double checking, make sure I didn't make any substitution errors. Okay, so it was a good idea just to double check. So we got here x is equal to, I'm running out of space, 85 fourths. We could plug that back in to check it, right? Maybe a good idea. Right, because it's not so pretty. Right, so let's see. And when you check it back into the original equation. All right, so we have, and before you reduced, 18 over 8 equals, right, so 85 fourths minus 1, that's 4 fourths. And divided by 9, and so we should simplify that. All right, so we have 18 eighths. That's supposed to be an 8. Right, so 18 eighths equal, that would be 81 fourths divided by 9. I don't know if I can squeeze this all in. Maybe if I move that up just a teeny bit. All right. All right, so, and that's divided by 9. So now dividing by 9 is the same as multiplying by 1/9. So let's do that. All right, so we can, we can reduce this. We should reduce it because that will, because the other one is going to end up being reduced. 18 eighths is going to reduce to 9 fourths, and that will reduce as well, equals 9 fourths. So you can see that does check out. I was a little worried when I got 85 fourths is my answer. The check, by the way, is optional. There are other times where we'll need to do a check, because that's actually part of the problem. But that's in the next topic. And so check here is optional. Maybe a good idea on a benchmark or a test or a quiz, something like that. All right? But that was our answer, 85 fourths. Can I squeeze that in there? I can. And we saw that it checks out. All right, so by the way, you don't want that complex fraction there. Dividing by something is the same as multiplying by the reciprocal. So I changed it to 1/9. All right, that's probably going to be one of the very few ones we check. And so now we've been working with just triangles, sides and triangles. But one of the best uses of similar triangles is to solve real-world problems. And there are a lot of real-world problems that couldn't be solved except indirectly through solving with similar triangles, right? Because if I want to know how tall a building is or how tall a mountain is, that's kind of hard to measure. But I can compare the similar triangles. I can compare corresponding parts, and I can solve. Because if two things are similar, their sides are going to be in proportion. All right, so here's our first one. A building casts a 103-foot shadow. Shadow is pretty easy to measure. It's on the ground. All right, so here's the shadow. And this, by the way, was the building. Here's its shadow. At the same time, a flagpole casts a, oh, let me write the numbers in there. So a building casts a 103-foot shadow. I didn't write the numbers in. I just identified shadow. There we go. At the same time, a 32-foot flagpole, so that's the height of my flag here, that's 32 feet, casts a 34.5-foot shadow. Round your answer to the nearest tenth. So how tall is the building? Round your answer to the nearest tenth. So to set up this, you want to draw a picture. Right? If you have this in words, I've already got the picture there, and this is in your notes. All of these are. If you don't have a picture, draw a picture. It will help you set up the proportion correctly. Because you don't just want to plug numbers in willy-nilly. Sometimes they don't give you a whole side. They give you part of a side. Right? But you can figure out the whole side based on your diagram. Right? Or at least your diagram will guide you in terms of how to solve. So to set this one up, you first draw the building, the flagpole, and a line for the flat ground. Right? So here's the sun in the sky, and then a nice sun. Right? So the lines indicate the sun's path. Right? So two things that are relatively near one another. Right? Sun's very large. It's going to create a shadow at the same angle. So the angle it hits the building is the same as the angle it hits the flag. Right? The sun is very, very big. All right? So that's going to give us we have two right triangles here because things like buildings and flagpoles, they're perpendicular to the ground. And then the shadow that the sun is hitting the flag and the building is exactly the same. All right, so we have two similar triangles here. And actually, let's write down how they're similar. So we've got two congruent angles. We've got angle, angle, triangle, similarity postulate. That's how we know that our two triangles here are similar to one another. Since the triangles are similar, you can set up a proportion and solve. Now when you're setting these up, make sure you've got a common thread in each fraction, all right? So you need a common, add that to your notes. So to each fraction, I did not leave myself enough space. I moved things up because they were just kind of low to the ground, low on the bottom of the screen there. To each fraction, the numerator, I'm going to abbreviate, and the denominator. All right, so here I've got each fraction's got, so one fraction's got flag, and the other fraction's got building. That works out. The numerator's got height, the denominator's got shadow. That works out. This isn't the only way I can set up this problem. I can move these around. So long as both of them are switched, it's all good. Now I've got shadow in the numerator, height in the denominator, and I've got flag in one fraction, building in the other fraction. I can do this. All right, so now I've got shadow in one fraction, I've got height in the other fraction, I've got flag in the numerator, building in the denominator. That works out. So what you can't do is have this. All right, so I'm going to switch these two. All right, so now I don't have a common theme. All right, I can't. Matter of fact, this is about as uncommon as possible. Even if I'll even switch these around, so they look a little bit. Now they still won't look alike. So I've got. Actually, this is fine. I've got shadow in one fraction and height in the other fraction. That's good. But look at numerator, building flag, shadow height. Nothing in common in the numerator. Flag and shadow, building height. Nothing in common in the denominator. So that's no good. All right. If you don't set it up so there's a common thread in each fraction, the numerator and the denominator, you can go and solve it, but the answer you get is black. It's meaningless. It's wrong, right? Because you didn't match corresponding parts, right? And so how you're gonna, you don't have a similar, you don't have triangle similarity statement here to match up the corresponding parts. You're gonna use, all right, the concepts, what these things are. Shadow goes with shadow. Height goes with height. Flag goes with flag. Building goes with building. All right. So I'll solve it like this because I've got a. Did I say? Oh no, I didn't move the things around. Did I? I've got shadow, shadow. Building, building. Flag, flag. Height, height. Yeah, I'm good. Okay, I moved them back. Couldn't remember if I moved them back. All right. So we've got shadow in the first numerator, in the first fraction, height in the second. We've got flag in the numerator, building in the denominator. That works out. So the flag shadow is 34.5 feet. And I'm not going to write it in words again because we've got it at the bottom. Right? So there's only so much room on this page. 34.5 feet. You can leave off the units, all right, until you're done. Building shadow is 103 feet. Flag height is 32 feet. We are looking for the building height, right? That was the unknown. How tall is the building? I did not mean to cross that out. I just meant to underline it. How tall is the building? All right. All right, so we're going to cross multiply. No meaningful reducing here. So x times 34.5, that's 34.5x. 32 times 100, and I'm going to write 32 times 103. We want to remember what we're multiplying. All right, so 32 times 103 is 3,296. We're going to divide both sides by 34.5. All right, so you can get a calculator out on this one. All right, so 3,296 divided by 34.5 is going to be 95.536 feet. I like more decimals rather than less decimals, but since I put in round to the nearest tenth, all right, x would be 95.5 feet. I personally don't take off if you don't round, as long as you don't round incorrectly. Oh, I have lines here to set up the proportion. I may as well write those in. But there's not enough room to solve down here, so I don't know why I put them there. I should move them up there. All right, and we're not going to check this one out, but you could. All right, and actually this wouldn't be too hard to check out because we know 95.536 times 34.5 is going to give us the same as 103 times 32 because, well, I divided 3,296 by 34.5, and that's how we got the 95.536 to begin with. Right? We'd just be undoing what we just did. All right, so here we're finding distances indirectly. This is how they measure, by the way, the width of a river. They don't swim across it. They wouldn't be able to do that, right? Because the river's moving. They're not going to be able to stay in a straight line. So to measure the width of a river, you use a surveying technique as shown in the diagram. All right, so here they want to measure across the river, but so just so you know, this right here is the river. All right. what they've done is they've gone, it's easy to measure along the side of the river, so this is 36 feet. They've measured this way. All right. They've measured, so from where they're measuring across on the river, they've walked out 12 feet. And then they've walked 9 feet, right? So that creates these two intersecting lines. We know that these two angles are congruent, right? Because those are vertical angles. Let's write that in. All right, so angle QRP is congruent to angle TRS because they're vertical angles. Right? And then so when they walked along the river, they walked perpendicular to the river. Right? So they've got two right angles there. So angle Q here, and it's fine to call that one angle Q. There's only one angle Q. Angle Q is congruent to angle T. Those are right angles. So we have two angles in the triangle congruent to each other. Of course, the third ones would have to be congruent using third angle theorem, but we don't need to do that because two angles is enough, because if we know two, we know three. All right, so by angle-angle similarity postulate, triangle PQR is similar to triangle STR, so we can set up a proportion. And now we just need to match the corresponding parts. All right, so RQ is going across the river, right? In the other triangle, that corresponds with RT. So by the way, in the numerator, I've put triangle QRP. Actually, since I called it PQR, let's call it PQR. PQR. And in the denominator, we're going to put triangle STR. And so RQ corresponds with RT. And PQ corresponds with ST. All right, so we've got one triangle in the numerator, one triangle in the denominator. Now let's replace that with the values. All right, so we'll substitute. So 1, there's our proportion in words. And number 2, we'll substitute the values. All right, so RQ is the one we're looking for. RT is 12. PQ is 63. ST is 9. All right, and we've got definitely some numbers we can reduce. All right, so let's do that. And so next to substitute values, I'm going to put reduce. It's not a requirement, but it does make the problem easier, as long as you do it correctly. All right, so the only thing you cannot reduce is the 12 and the 63, but you can reduce the 63 and the 9. And actually, once you've done that, it's pretty much all you can do, because they're both divisible by 9. Right? So 9 goes into 9 one time, and 9 times 7, right, would give you 63. All right, so that's as much reducing as you can possibly do. So now, step 3, we'll cross multiply. And actually, that's all we're going to have to do, right? Because x is already isolated. So 1 times x is x, and then we have 7 times 12, which is 84. On real-world problems, by the way, don't forget to put in the units of measure. We already have it in there in that spot. So the river is 84 feet wide. Right? They couldn't measure it directly, but they can measure it indirectly using similar triangles. And we've done another problem. Let's continue on. All right, so using similar triangles. A lifeguard is standing beside the lifeguard chair on the beach. The lifeguard is 6 feet 4 inches tall. He's a little bit skinny fellow right over here. He doesn't eat much, all right, so he's skinny. And creates a shadow that's 48 inches. The chair casts a shadow that's 6 feet. How tall is the chair? So the lifeguard and the chair form two sides of two right triangles with the ground as shown below. All right, so people and chairs are perpendicular to the ground. And then the sun hits both of those things with the same angle. And so you can think of it as how the sun hits here or how the sun hits here. Either way, this angle is congruent to this one. This one, by the way, would also be congruent. All right? Both the angle the sun makes with the ground and the angle the sun makes with the person in the chair are the same. Well, it's not the angle the sun makes with the person isn't the same as it makes with the ground, but the angle it makes with the person is the same as the angle it makes with the chair, and the angle it makes with the ground is the same in both of those. All right, so you have two pairs of congruent angles, so the triangles are similar by angle-angle postulate, and I believe that's in your notes. So you can use a proportion to find the height, but you have a problem. You cannot work with two different units. So let's just add that in. You can't work with two different units. You either have to change it all to inches or all to feet. It's probably easier to change those all to inches, all right? And then you're going to have inches in one and feet in the other, all right? The other thing you can do is just change it all so you've just got all the same unit of measure to begin with, and you don't have to worry about, do I have this set up right? Because when you're working, you have to make sure that inches are together and feet are together. All right? So it might be easier if we change everything to inches. All right? But anyhow, let's change that 6 foot 4 inches. That 6 feet, 6 times 12 would be 72 plus 4 more. He's 76 inches tall. So let's set up our proportion in words first. All right? So I'm going to abbreviate LG for lifeguard. So lifeguard shadow, right, is equal to lifeguard, and so I'll put lifeguard shadow, and then we'll put chair shadow. And then we have lifeguard height. Chair height. Now if we set it up this way, we can have inches in the numerator and feet in the denominator, and it should work out. If you have any problems though, because we've got everything lifeguard is in inches, if you have any problems, you can just make everything in inches and then you don't have to worry about it. Let's try it both ways and see if we get the same answer. All right? So 48 is the shadow. And the chair shadow is 6. The lifeguard height is 76. He's not 100. Did he grow? And the chair height is what we're solving for. Now, if we've done this correctly, all right, feet's in the denominator. So whatever we get, it's feet. We can reduce here. Eight and 1. And I quite honestly actually prefer to change it all to inches and just have one unit of measurement, and then I don't have to worry to make sure that I've set it up correctly. So we're going to solve it both ways, all right, with not changing everything to inches, and see if we get the same thing as when we change everything to inches. All right, and then technically we could reduce here in the numerator. They're both divisible by 4. So this would be 2, and let's see, 4 would go because 8 won't divide evenly into 76, but 4 will. 4 will go in 19 times. All right, so now if we've done this correctly, all right, so x is equal to 2 times 19, excuse me, 1 time, 2x, so sorry. Lost where numbers were. My shadow is blocking a little bit. So my shadow. So 2x is equal to 19. And divide both sides by 2. X is 8.5. And that is feet, right? Because we said that inches is going to be numerator and feet is going to be denominator. If we mix them up, it's not going to work out, right? That's why I had to do lifeguard shadow, lifeguard height, because they were inches, and chair shadow and chair height in the denominator because they were both feet. Now, what if you don't want to have to worry about that? All right, change them all to inches, right? And it wasn't that hard because we could just change. So let's just put another way. So let's just put method 2. Change everything to inches, all right? And then your answer is in terms of inches. All right, and that's fine. Nobody said it had to be feet. It could be feet, could be inches, whatever you want. All right, so it's going to be the same except for the 6. All right, so here we have the 48 and the 76. They're going to stay the same. And the 6 is now going to be, because we're changing it to inches, so 6 feet is 72 inches. So now our answer is going to be in terms of inches, not feet. All right, and so we can do a little reducing. So 48 and 72 are divisible by 12. Anything else? I don't know. Let's divide it by 12. And so that would be 6, and that would be 4. All right, well, I could have said 24, right, because we got one more 2 here. So this would be 2, and this would be 3. And then the 2 and the 76 could be reduced. So 2 goes into 2 one time. And by the way, be really careful with your numbers that you don't lose numbers. And so we're just dividing the numerator, both of them by 2, because you can reduce within a fraction, numerator to numerator, denominator to denominator. So I can divide both terms in the numerator by 2, and you don't have to, but it will make smaller numbers. So 2 is going to go into that 38 times. Yes. All right, so now if I multiply, I have 1 times x, so that's x, equals 3 times 38, which is 114? 90 plus 24, yeah, 114. And you're going to say, you might say, hey, wait a minute, that doesn't match. You've got 114 now. What's going on, Ms. Mashagna? All right, well, that's inches. And 8.5 is feet. And I am not too far away from a calculator. And so now if I take a handy-dandy calculator and divide 114 by 12, we get, oops, well, 9.5, because I accidentally, since when is 19 divided by 2 8.5? That's 17. I don't know, maybe I looked at it and thought it was 17. Well, anyway, it's a good thing we did it 2 ways, because I caught my mistake, 9.5 feet tall. You know, it's always the little things with me. I'll do all the hard things right, and then I made a mistake dividing by 2. All right, so 9.5 feet tall. And so 114 inches is equal to 9.5 feet. They are the same. All right, and it doesn't matter which units you use. And I think this might be a good stopping point, because I already have a video on this podcast, on this Nearpod, and this is the second video, and I'm already at 34 minutes. So I'm going to stop this video now, and then in the next podcast, actually the next Nearpod, we're going to look at solving a couple more problems, only 2 more, including this fascinating dinosaur problem. So stay tuned to the next Nearpod, and we'll solve those and many more. Bye for now.